Hello everyone, my name is Vivek Bahadur Shrestha. I welcome you all in my online class, Drawing and Storage Engineering. I am an assistant professor in Department of Applied Engineering, Vignan's Foundation for Science, Technology and Research University. This course, it mainly helps you in different aspects like NET exam or ARS exam or GATE competitive exam. These courses are available, so a lot of scores you can carry after studying this course. So I hope you all stick to my online class very hard, so you will understand each and every concept of this course. So coming to next slide, we have here course description. It covers fundamentals of drawing and storage, basic concepts of drawing and application of this concept for design of drawers, fundamentals of storage followed by design of different storage structures. So here we have course outcomes. It gains knowledge about drying and storage of various crops, various drying and storage techniques of agricultural products. Next, we have total 5 units available in our course Drying and Storage Engineering. So these 5 units has been depicted here. So first unit you see moisture content and method of determination, importance of equilibrium moisture content, that is EMC curves and models, principles of drying, theory of diffusion, constant rate and falling rate drying, then thin layer and deep bed drying, critical moisture content and drying models. In second unit, you have calculation of drying air temperature, flow rate, puff drying, format drying, flitch drying, different dryer performance, energy utilization, efficiency of drying products. In third units, you have causes and spoilage of storage, condition and functional requirement, control of temperature, RH and refrigeration load. So here we have coming to fourth unit, we have here modified atmosphere packaging, MAP, controlled atmosphere packaging, CAP, air movement inside storage, destructive agents at storage condition, respiration, moisture content, temperature change, and air conditioning. The last unit consists of different storage structures, storage of cereals, seed, and etc. And last, economic aspect of storage. So here throughout this course, we'll be learning what is drying, how drying happens, or what mechanisms are there or that are gone through inside the product, and why this drying is so necessary before storage or different storage structures, their uh, designing, design consideration. So all these things we'll learn throughout this course. So here we start our first day of online class. So before we start this drying and storage engineering, it's required to clear some doubts or clear some concepts on some similar terms. So there is the terms drying and evaporation. These both terms are quite similar in their meaning, but their functions or there is some differences or lies behind it. So here drying, it removes moisture, and evaporation also removes moisture. But yes, there is a difference. Drying removes moisture mainly from solid body, or the output of the product we get from drying is solid body, whereas in evaporation the output of the body is your liquid. So you see here in the slides it's written drying removes water from solid materials, evaporation removes water from liquid materials. So the next one, drying occurs below boiling point most cases, and evaporation occurs above boiling point most of the cases, but every time it's not true. So in the next Another two terms, it's quite familiar, is boiling and evaporation. So there also some differences are there. Boiling, it's occurred at a particular temperature or at a particular pressure, but evaporation, it doesn't need that particular temperature. It can occur at any temperature. Uh, so here you see boiling occurs at a fixed temperature. Evaporation occurs at any temperature, of environment. Boiling is generally a quick process, whereas in evaporation it takes lot of time. Boiling, it occurs throughout the liquid. Okay, so throughout the liquid boiling takes place, but uh, while talk about evaporation, it occurs only at the surface. Only at the surface it occurs. uh, Boiling, there is a formation of bubbles, but in evaporation there is no formation of bubbles. And during boiling the temperature remains constant. The first point I mentioned, that boiling occurs at fixed temperature. That means, suppose at 1 atmosphere pressure, if you want to boil water, you need 100 degrees Celsius temperature. So throughout boiling you must maintain 100 degrees Celsius for boiling, but for evaporation you don't have to maintain the temperature. If the temperature change, still the evaporation continue, can be continued. So this is the difference between boiling and evaporation. Next, you have drying and evaporation. Sorry, drying and dehydration. Now, drying, when we talk about drying, it's not at a particular temperature, or it's the environmental condition we maintain that is not fixed. But for dehydration, the environmental condition is fixed one. So, relative humidity or temperature. So these are the environmental condition. So for dehydration, we must regulate, or we must maintain that condition at a fixed point. Okay. So here you see drying mainly uses non-conventional energy source such as sun, wind, but dehydration uses heat under controlled condition, temperature, relative humidity, and airflow or airflow rate. And drying is an uncontrolled process, and dehydration is a controlled process. So in this particular slides we learned about drying and evaporation difference, the difference between boiling and evaporation, and the difference between drying and dehydration. So you see, in drying and evaporation, drying removes moisture from mainly solid product, and in evaporation it removes moisture from liquid product. And in boiling and evaporation, boiling mainly occurs at a particular temperature, but evaporation can occur at any temperature. And in drying and dehydration, drying is a uncontrolled process and dehydration is a controlled process. Coming to next slide, you have here introduction to drying. So the main parameter or the main culprit in drying is your moisture content. So how this moisture content affect drying process, or is it necessary that moisture content inside product? So this topics or this concepts are written here. So you see it plays an important role in maintaining desirable quality of product. Means the desirable texture, or the palatable quality of the product. To maintain this quality, we must need a certain amount of moisture content inside product. Next one, you see, affects quality during harvesting, processing, and marketing. Initial moisture content, atmospheric condition, equilibrium moisture content. This particular term we will learn after a while. It gives necessary information about product's quality, their metabolic reaction during storage. And the last one you see, with increase of moisture content in food, it reduces the viability of seed. So for all these reasons, drying is necessary. Okay. Here you have some points on importance of moisture content. storability, causes agglomeration in case of powder, protect from microbiological stability, affects flow properties, viscosity, gives nutritional value and legal conformity, affects concentration of product, changes commercial grade. So till now we have discussed about this moisture content. Now as an engineer, how will you represent the moisture, or is there any way of representation? Yes, there is two way of representation of moisture. One is weight basis, another one dry basis. So before we start this, first you must remember that mass of product or the product is nothing but, it consists of some amount of solid, some amount of moisture, some amount of void space or air space. Now, this, you take an example, if 100 grams of paddy you have, in 100 grams of paddy, you have 50 grams of solid, you have 40 grams of moisture, and rest is 10 grams of void space or air space. Now, what is this 50 grams of solid? That 50 grams of solid means carbohydrate, protein, fat, minerals, as. So these are my solid content. And then 40 grams of moisture, and then 10 grams of void space. So this whole consists of 100 grams of paddy. So this is your mass of product. Now this mass of void space is very less. So while solving numericals or giving concept, you must or you can neglect mass of void space. But you must remember the volume of void space is not negligible. Okay. So mass of air space is negligible, but volume of void space or volume of air space is not negligible. Okay. So now already I told you that there is two way of representation of moisture. One is weight basis moisture, another one dry basis moisture. So this weight basis and dry basis moisture can be identified, can be given in percentage or in decimal. Okay. So what is this weight basis moisture then? This weight basis moisture is nothing but amount of moisture, means how much moisture is present out of how much product or how much total product. So already I gave you example. If you remember this, out of in 100 grams of paddy you had 40 grams of moisture, okay, and 50 grams of solid. So weight basis moisture means, or percent of weight basis paddy means, it will be 40 divided by 100, means mass of moisture present in mass of product. So that's why I can write this weight basis equals to mass of moisture content present in product divided by mass of product. So if I give some nomenclatures, then we can write WB equals to mm by mp. So what is this mm? Mm is mass of moisture. What is mp? Mass of product. So this mass of product, again it can be simplified into two, because mass of solid plus mass of moisture, because you have neglected the mass of void space. So finally we can write WB equals to mm by ms plus mm. Now in same way we can explain dry basis moisture also. So now how will you define this dry basis moisture? Now if you remember the weight basis moisture, there you have represented the amount of moisture out of total product or out of total mass. Now in dry basis moisture we represent this amount of moisture present out of solid mass or out of solid present in product, not out of total mass. So as for example, if you remember, in 100 grams of paddy you had 50 grams of solid, 40 grams of moisture, and 10 grams of air space. So how will you define this dry basis then? Dry basis will be 40 grams of moisture present in 50 grams of solid. So 40 divided by 50, it's nothing but percent dB or in decimal. If you multiply this value with 100, then we get the percent dB, and if you keep it as it is, then we get in decimal. So dry basis we can write as mass of moisture content present in product divided by mass of solid present in product. Okay, so dB equals to mm by ms. So mm, same, mass of moisture, ms, mass of solid. Now we'll find out the relation between dry basis and wet basis. So if we start from wet basis, so what is wet basis? Again, as per saying, mm divided by mp. This mp can be classified, or again it can be simplified into two: mass of moisture plus mass of solid. So in the next line I can write WB equals to mm by mm plus ms. Now both sides, if we reverse it, so what happened? The left hand side becomes 1 by WB, and the right hand side it becomes, if I reverse it, it becomes mm plus ms divided by mm. Okay. Now in this line, if I split this right hand side, into 2, it becomes 1 by WB equals to mm by mm plus ms by mm. Next, so mm by mm, I can cancel these two terms, so it remains 1. So finally we get 1 by WB equals to 1 plus. Now we look at this second term in the right hand side. It's ms by mm. That means mass of solid by mass of moisture. But we have dry basis formula. The dry basis formula is mass of moisture by mass of solid. So this ms by mm term I can write in 1 by dB. So I've been writing here 1 by WB equals to 1 plus 1 by dB. So finally we get the equation. If I, after simplification, WB equals to dB by 1 plus dB. So this is the value of WB in terms of dB. Now in reverse way, if you want to write the value of dB in terms of WB, then the formula becomes dB equals to WB by 1 minus WB. So these two values we can prove, and these two values are given in percentage or in decimals. But while solving numericals, it's better, it's always suggested that put the values of WB or dB or moisture values in decimal. Don't put the values in percentage. Okay. So while solving numericals, you keep in mind that WB or dB values should be in decimals. Now one concept is there, that out of this WB or dB, which one is higher? Now the examples I have already given you, you must just try to recall that. So 100 grams of paddy contains 50 grams of solid, 40 grams of moisture, and 10 grams of air space. So if I calculate the value of WB of paddy, then as per formula, mass of moisture, that is 40 divided by mass of product, means out of whole mass how much amount of moisture is available. So I can write 40 divided by 100, means it's coming 0.4. Okay. Now in the same way, if I want to calculate the value of dB, so dB means amount of moisture present out of total solid. So how much solid was present in paddy? 40 grams. So now dB value becomes 40 grams of moisture divided by 50 grams of solid. So we can write 40 divided by 50. So it's coming 0.8. So if you compare this WB and DB, it's coming DB value is higher than WB. Okay, so always the value of DB is higher than WB. You must remember it. Why it is so? Because in DB term, we don't take or we take the mass of moisture out of solid mass, only solid mass. But in WB calculation, we take the mass of moisture out of solid, out of total mass. In that out of total mass, we include mass of moisture and mass of solid. But in DB, we only take care of, means we only take care mass of moisture out of mass of solid. So that's why value of DB is always higher than value of WB. Now there are several methods of determination of moisture, because till now we have discussed this way of representation. Means if we have some 20% or 40% moisture, so how can we represent this moisture in W basis, in weight basis, or in dry basis? Now how will you determine the moisture that 20% moisture is present? How will you determine? So there are two methods available, mainly direct method and indirect method. So what is this direct method? In direct method, we determine the amount of moisture directly by experiment. Okay, but in indirect method, we don't calculate or we don't evaluate the moisture directly. We calculate indirectly. That means, suppose moisture content is a parameter which depends on other parameter. Okay, maybe it is electrical conductivity or electrical resistivity or some other parameters. So if we calculate the value of that parameter, means electrical conductivity or electrical resistivity, then with after relating that electrical conductivity and moisture, we can find out the moisture value indirectly. So as an example, I can say that this paddy, the paddy has a certain amount of electrical conductivity. Okay, so if by method, indirect method, if you calculate the value of electrical conductivity of paddy, and after calculating electrical conductivity of paddy, if we compare or if we relate this value with moisture, then I can tell you the value of moisture inside the paddy. So this is indirect method. Now you see some difference is written here. Direct method is more accurate, obviously, because we calculate the moisture directly by experiment. But in indirect method, we are taking care of some other parameters, and then we relate that parameters with moisture, and then we find out the moisture. So this is a less accurate process. So direct method, it's a more accurate, so that's why it's used in research process or research work. But indirect method, it's not used in research work, but still it takes less time to calculate the moisture. That's why it's dominantly used in industry. And the last same, it's more time consuming process, and indirect method, it's less time consuming process. Now before we start this several drying methods to calculate moisture content, we should have a knowledge about their equipments or apparatures. So first you see moisture is heavy gauge aluminum sheet material. But one note is there, you see, before use in drying, it should be dried in oven for 1 hour. Now why it is so? Now as an example, I can say that suppose you are calculating moisture content of paddy. Now while calculating the moisture content of paddy, you don't want to incorporate other moisture content of other components, right? So if we use this moisture dish, and in this moisture dish if you keep paddy for drying process, then maybe there is a chance that moisture dish contain some amount of moisture. So while experimenting, you unknowingly include the moisture content of moisture dish inside this paddy moisture. So to avoid this, we must remove the moisture content of moisture dish after drying. Next, another one important apparatus is there, desiccator. Desiccator is nothing but it's just prevents the escaping of moisture. It's very active absorbent inside is present, and it's very much airtight container. So inside this there is no chance of in or out of moisture. Now another one apparatus is there, oven. Oven is highly known to all of you. It's convective type dryers, heat resistant, proper arrangement of air circulation, perforated trays are available, suitable thermometer is there. Now another one is there, weighing balance. So this weighing balance, it calculate the or it gives the weight of product analytically. Now there are some direct methods available. So first method is the air oven method. Now in this air oven method, products having less than 13% moisture is mainly used for this method. 2 to 3 grams of sample is taken for air oven method. Now why this small amount of sample is taken? Why don't you take a large amount of sample? The reason is, if we take small amount of sample, then the surface area of the product will be much more exposed. Now you just take an example. If you take some product, some raw material such as take some dairy product, paneer. Okay, so you take a cumulative mass of paneer, and now you want to calculate the moisture available in that paneer. So if we take the whole cumulative paneer inside the dryer, there will be less surface area exposed to the dryer. So in this case, if less surface area is exposed, that means more time will be needed to dry the product. But same time means at the same time, if we take the fragment of paneer, means if we just reduce the size of paneer, and that reduced size of paneer if you keep inside the oven and you dry it, then you will find less time will be required. Why? Because more surface area is exposed for drying. So that's why less weight of sample is first taken. 2 to 3 gram sample of product is placed in air oven. Then product is kept for 130 degrees Celsius for 1 hour, and then the sample is placed in desiccator to cool down. Product having more than 13% moisture, so for that type of product we do the drying for 103 degrees Celsius plus minus 1 some error for 72 hours. Now one question will come, how long we have to dry, or how do you know that the drying is completed? So there is a concept. While drying a product, we take the weight of product continuously or after 1 hour, 1 hour. So as an example, you are determining the moisture content of paddy. So first you keep the paddy mass inside hot air oven and you start drying. So after 1 hour of drying, you take the paddy out of dryer and you weigh the paddy in weighing balance. Now while weighing the paddy, you will find out that there is a reduction in weight. Why this reduction in weight? Because some portion of moisture is escaped, as evaporation. Now, is there any chance of anything else except moisture? No, there is a no chance, because in product there is only available thing moisture, solid and airspace. That airspace already you neglected. Only the present thing is solid and moisture. And we know that after drying there is impossible to change in solid mass. So only the change occurs in moisture. Now, after reduction in moisture, again you keep in oven. Again, after 1 hour, you take down or you note down the moisture value, or weight of the paddy. So you continue the process until and unless the weight of the two weighing becomes same. Means one point will come. Suppose at that point, if you weigh the product, it comes 10 grams. Okay. After 1 hour, again if you continue the dry process and again if you weigh the paddy, it again comes 10 grams. That means there is no change in weight. So that means you must assure that your drying process has been completed. Okay. Next, there is two way of representation, %WB and %dV. So how we can write this %WB? You see here, W1 minus W2 by W1. What is this W1? Weight of initial product or initial mass, and W2 is the final mass of product. That means it's nothing but mass of solid. There is no moisture available. So if we subtract these two values, we get mass of moisture. So as per weight basis concept, mass of moisture present in out of total mass. That means initial mass is W1. So this is the formula, W1 minus W2 by W1. And %dV, same, mass of moisture present, mass of solid. Okay, present in mass of solid. So I can write W1 minus W2 divided by W2. So now another one method is there, vacuum oven method. In vacuum oven method, 2 to 3 grams of samples are taken, and by its name, we don't try this or we don't try the product in above atmospheric pressure. We dry the product below atmospheric pressure, that is in 25 mm vacuum at 106 degrees Celsius for 72 hours to 96 hours. Okay. So this is your air oven method and vacuum oven method. So in air oven method or vacuum oven method, we dry the product, but finally you remember, until and unless the weight of two consecutive weighing becomes same, we must continue the drying. Next, there is a temperature and time combination of drying of different agricultural product is given: wheat, sorghum, maize, mustard, sunflower, safflower and bean. So here you can find out, or here you can see the temperature and time combinations are given here. Now another one direct method is there, Brown-Duval fractional distillation method. In Brown-Duval fractional distillation method, we take 100 grams of whole grain and 150 ml of mineral oil. This content we take into a flask, and this sample is boiled, and then moisture content from the sample is evaporated, and then it is collected and condensed in graduated cylinder. So in that graduated cylinder we have mark. Okay, we have mark. So with the help of this mark we can calculate the percent of moisture. So here temperature of mineral oil in the flask should reach to 200 degrees Celsius within 26 minutes, and time required for moisture content determination is half an hour or 30 minutes. Coming to another one direct method is your infrared method. In this infrared method, we take the help of infrared lamp So with this help of infrared heating lamp, we remove moisture from product and we calculate the percent of moisture in wet basis or in dry basis. So moisture content is directly measured by evaporation of grain by infrared heating lamp. It consists of balance, pan, variable length of weighing chain. Iron lamp is mounted on arm with pan provision to change its height. If the ground sample is used, then time requirement is reduced. Next comes to this indirect method. So in indirect method, we already told, we already know that moisture content is not measured directly. It is measured with the help of some other parameters. Those parameters are related to moisture content. So you see here the first one, electrical resistance method. In this electrical resistance method, electrical conductivity or electrical resistivity of product depends on moisture. So with the help of this concept, we calculate the amount of moisture inside product. So electrical conductivity or resistance depends on moisture content at given compaction and temperature. Universal moisture meter is a device which is used to measure moisture content in indirect method. Next method you have dielectric method. Now what is dielectric? Dielectric is the amount of energy that is penetrated inside the product. I'll give you an example. Suppose you take some fruits, apple, okay? You take some apple and you apply some energy. So by loss, or generally the energy will be penetrated inside the apple, okay, up to a certain depth. So the amount of energy is penetrated inside the apple is nothing but the dielectric, and the amount of energy is lost from apple is called as dielectric loss. So with the help of this parameter, we calculate the percent of moisture. So that's why this method is called as indirect method. Means in this method, we take the help of dielectric and then dielectric constant, and by the help of this dielectric constant of grain, we calculate percent of moisture. So you see here, measure dielectric constant of grain. Grain is filled in chamber. The side of chamber is formed by plate of condenser between which high frequency current is passed. So this is the energy we are giving to the product. Passed to measure capacitance of sample, and this capacitance, the property, is proportional to moisture content present in sample at a certain degree of compaction and temperature. Now already I mentioned that this direct method or indirect method is not so accurate. Why? Because all the properties we calculate, we must calculate at a particular temperature, of grain. Now it's quite laborious to calculate the temperature of grain, while we can calculate the temperature of air so easily. So in place of temperature of grain, we take temperature of air. So this is the error we do while calculating moisture content by indirect method. So you see here, electrical properties of grain is proportional to temperature. Measurement of grain temperature is difficult, so ambient air temperature is often used, and it results a source of error. So because of difference in grain and air temperature. Now another one indirect method is there to calculate moisture content of product. Here we do the chemical analysis. So moisture content is removed by using strong desiccant, that is the absorbent moisture content absorber, namely calcium chloride. So as vapor pressure of grain is greater than vapor pressure of desiccant. Now what does it mean? So vapor pressure of grain is greater than vapor pressure of desiccant. That is my calcium chloride. So if vapor pressure of calcium chloride is less than vapor pressure of grain, that means naturally the moisture of grain will move from grain to desiccant or calcium chloride. So that's why calcium chloride naturally absorbs moisture from grain. So that's why calcium chloride is called as absorbent, okay, or desiccant. Means the vapor pressure of the grain is more than vapor pressure of calcium chloride. Now, hydration of salt is done by evaluation of heat, and this heat of evaluation drives out water from grain. So, one equation is given here. You see, calcium chloride plus 2 molecules of water, it produces, or it liberates calcium hydroxide plus 2 HCl. So, by measuring the volume of HCl, we measure the moisture content amount in percent dB or percent WB. Now comes this equilibrium moisture content term, or EMC. So before we discuss about equilibrium moisture content, first you must remember that grain contains moisture and air contains water vapor. There is a difference between these two. Water means it's in liquid state, okay, but water vapor means it's in gaseous state, okay. So air contains water in gaseous state, but product contains moisture in liquid state. Now the difference between two means the amount of moisture or amount of water vapor in air, there is a difference. It should not be like that always moisture in grain or moisture in air must be in equilibrium. So as an example, if we take paddy, so paddy contains some portion of moisture. So this paddy, if we keep inside at environment where this environment contains some portion of water vapor. Now let's take a assumption that moisture content of grain is less than water vapor in air. That means there is more amount of water vapor present in air than moisture content of grain. That means air's humidity is much more than paddy's moisture. So in this case, from where to where the moisture movement will occur? Now naturally the movement occurs from high to low. So in this case the water vapor is much more in air. So air will lose moisture and paddy will gain moisture. That means in this example paddy gains moisture, means paddy rehydrate or paddy becomes hydrated. If you take the same example and if you reverse the same process, then as per assumptions, if moisture content of paddy is more than water vapor in air, that means if water vapor in air is less, if water vapor in air is less, means the air is not humidified air, or air is much more dehumidified air or much more dried air. So in this condition, if you keep paddy, that in this case same the law is same, from high to low moisture movement occurs. So as moisture content of paddy is much more than water vapor in air, so paddy will lose moisture and air will gain moisture. So in this case paddy gradually dry in this environment. So to dry a product, we must remember that we must keep product, or we shall keep product at dehumidified air or at dried air. So after this movement of moisture from product to environment or from environment to product, the moisture content of product becomes equilibrium or it becomes equilibrium with environment, and that moisture content of product is known as equilibrium moisture content. So here you see food product absorb or loses moisture content from environment or to environment depending on its temperature and relative humidity, means how much amount of water vapor present in air or atmosphere. So moisture content is a function of temperature and relative humidity. If vapor pressure of water present in grain is more than vapor pressure of water vapor in air, then product loses moisture content. Why? Because if grain contains more water and air contains less water vapor, then as per law, from high to low, the grain will lose moisture and air will gain moisture. So dry occurs. And same thing, just reverse it. If vapor pressure of water present in grain is less than vapor pressure of water vapor in air, then product absorb moisture, means product is hydrated. Product absorb moisture and hydration occurs. So this property of gaining moisture or losing moisture as per atmospheric condition, so this phenomena is called as hygroscopicity. Okay, so this phenomena is called as hygroscopicity. So at a single line, if we want to define equilibrium moisture content, it's nothing but the moisture content of product at which the vapor pressure of grain or the vapor pressure of water in grain equals to vapor pressure of water vapor in air. So these two if becomes equilibrium, then the moisture content of product will be known as equilibrium moisture content. And this phenomena of gaining or losing moisture from product or to product is known as hygroscopicity. So here you can see equilibrium moisture content after absorbing or losing moisture from environment or to environment by grain with respect to temperature or RH is known as equilibrium moisture content. Grain moisture content becomes equilibrium with surroundings. A plot is drawn between equilibrium moisture content and equilibrium relative humidity of particular material at definite temperature. And this plot is known as equilibrium moisture content curve or isotherm. So I'll give you one picture of this equilibrium moisture content curve so you can realize, and it generally looks like S. Okay, it's generally S set. So here you can see this is your Jobson isotherm or equilibrium moisture content curve. In this equilibrium moisture content curve, in y-axis we have taken equilibrium moisture content and in x-axis we have taken relative humidity. Okay, so this relative humidity is nothing but, or we can define it as the vapor pressure of water vapor present in air divided by vapor pressure of water vapor present in saturated air. Now what is saturated air? Saturated air means in this saturated air the vapor pressure of water vapor is 100%. Okay, that means the air is fully saturated with water vapor. So if we want to calculate the value of relative humidity of a particular air, suppose, say for example, right now we are sitting at a particular environment. So for that environment or for that atmospheric condition, we have to know the value of water vapor or the value of vapor pressure of water vapor of that particular air. And that particular air is present at a definite pressure. Okay, so for this pressure, what is the value of vapor pressure of water vapor of that saturated air? So if we divide these two, then it is known as relative humidity. Relative humidity is nothing but just comparison of air atmospheric air's water vapor or vapor pressure to saturated air's vapor pressure. So if we compare, then we get the value of relative humidity. If the value of relative humidity is 100%, means you are sitting at such at environment where the vapor pressure of water vapor is equals to vapor pressure of water vapor in saturated air. Okay, so like this, if you plot a curve between this equilibrium moisture content and equilibrium relative humidity, we get one S-shaped equilibrium moisture content curve or Jobson isotherm. Okay, so here I would like to end my today's first online class on drying and storage engineering. So today what we studied is like we mainly studied the introductory part. So first we have seen that in drying and storage engineering courses there are several topics like what is drying or why drying necessary, what is equilibrium moisture content. There are several equilibrium moisture content curves or models are there, and different design parts, design of different dryers or different storage structures. So these topics are there in drying and storage engineering. And then we have seen that moisture content. Okay, we have seen the way of representation of moisture content. There is mainly two way of representation of moisture: weight basis moisture and dry basis moisture. And in weight basis moisture, the way how do you represent it? The amount of moisture present in out of total mass or out of total mass of product. But in dry basis moisture, the mass of moisture is presented out of solid matter or out of solid present in product. Okay, so this is weight basis and dry basis moisture, and this both can be represented in percentage or in decimals. And while solving numericals, which one you will try? Will first keep only decimals. Okay, which will try to put the decimal value of weight basis and dry basis in problems. And then we have seen the methods. Okay, there are two methods of determination of moisture. So direct method and indirect method. Direct method, here we directly measure the moisture by air oven method or vacuum oven method or infrared method or brown Duvel fractional distillation method. But in indirect method, we don't directly measure the moisture. First, we calculate some parameters. Okay, those parameters depend on moisture value. So by calculating the value of that parameter, we indirectly calculate or we indirectly predict the amount of moisture in product. So in that method we had chemical method, then we had electrical conductivity method, then we had dielectric method. So this all we studied, and we have seen that in indirect method, in place of rain temperature we take air temperature. So because of this error of this, we find that indirect method is less accurate than direct method. And then we have seen equilibrium moisture content. So what is equilibrium moisture content? It is nothing but moisture content of product at which vapor pressure of water vapor in product becomes equilibrium with vapor pressure of water vapor present in air. So if these two becomes equilibrium, then
the moisture content of product is known as equilibrium moisture content. But till then there is a gain of moisture or there is a loss of moisture. It happens. Why? Because of the gradient of the water vapor. So that's why this phenomena of gaining or losing moisture is called hygroscopicity. And we have seen one curve that between equilibrium moisture content and equilibrium relative humidity. So in x-axis we presented equilibrium relative humidity, and in y-axis we represented equilibrium moisture content. So if we plot the curve, then it looks like a S-curve. This S-curve is known as equilibrium moisture content curve or Jobson isotherm. So till now, today we have discussed. So in the next online class, we'll be discussing on equilibrium moisture content models. There are several models are there. Then there are different methods to determine equilibrium moisture content. So, and then there are principles of drying. So these topics will cover in our next class. Okay, thank you.